So you guys just made your prediction using our particle model to predict whether food coloring will move faster in hot or cold water. So, Handi, what do you think? Khalil, which one's going to move faster?
I think in the hot water, because the hot water particles move faster.
Okay. Khalil, do you agree? Is that what you guys came up with? All right, so what I'm going to do is start my timer. We're going to drop a blue dot in both. So we'll start in the cold. Ready? I'll put one drop in. So there's one. Start my timer. I'll be about 3 seconds behind. We are going to try to observe which one goes quicker. We've got to decide when it goes halfway. So I'm watching. Ooh, it's close to halfway. We are at 16 seconds and we're about halfway. If you need to just go down a little bit, that's okay. To try to get that swirling effect. My cold isn't really moving. Now I don't want to stir it. I don't want to disturb the water. But in 16 seconds, I was at half. We're at 33 with the other one. She's just going to keep videotaping, which is not exciting. So I'm going to go to my data. Okay, Alex, can you walk forward? All right, walk forward. Then take a picture of this. Keep walking.
Okay.
Keep walking.
Should I stop the video?
No!
Keep walking. Okay, so at 16 seconds, we already had half of our hot water colored. Okay? But we don't have any change on the cold water. Now, how was the color spreading? How could you guys describe that? Cora?
Swirly, twirly.
Okay, so on the hot, it would be swirly, twirly.
That's like weird.
Okay? What about the cold? If I look at it from here, Matthew K., what are you noticing?
It's not moving very fast.
But what shape is it in right now? Lily, what are you noticing? It's very still.
Kind of like a...
Pierce?
I think it's kind of frozen almost, kind of.
Okay. Jack,
Like
four on the floor.
Or it's like, or like.
It looks almost like a column, though.
Yeah.
Like it's just
Tornado.
straight down.
I think that it was a
Okay? Now, I'm going to get some more data. I need to measure my temperature.
Go over
This is
there.
new liquid.
cow milk.
No, you're not.
So,
Oh my god, you really irritating.
my hot one is 61 degrees.
I have to go.
And my cold one, I don't want to stroke the water. Ooh, it's going the other way. So 61 degrees. Awesome. Thanks, Mr. Dobie. And my cold one is, it's still dropping. It's at 8, but we're still dropping.
Wait.
Always Celsius, honey. 3 degrees.
3?
3 degrees for Celsius, for the cold. Okay? So with that big change, does that support, how does that predict, or does that fit our prediction? Did everybody think that the hot would spread faster?
Yes.
Okay, why do you believe that? Can you go back and put it on the water again? Awesome. I'm gonna try not to get anybody on the pictures except the bottles and me. So he's doing a great job. So on the bottles, perfect. So number 1 in our books, Khalil, is asking how does your prediction compare? That's where we're looking right now. So Ava, how does our prediction compare?
I said hot water
So you were correct?
Yeah.
Oh, then your prediction was correct. If you said the cold water, then you'd be incorrect, okay? So then we look at number 2. What does an increase in temp tell us about the movement of molecules in a liquid? We've only been studying gases. So what does it tell us about the movement of liquid particles? What do we know, Cameron?
Well, I think that in the liquid, an increase in temperature means the molecule will speed up, and the more they speed up, I guess the warmer it is, and if it gets warm enough, it'll go into a gaseous state.
Okay, so this isn't warm enough to go gaseous, but does this support it? If we look at these results, this cold is moving so slow that the blue isn't even spreading. The hot, though, was moving so fast that the whole beaker is already turned blue. Does that fit? Is that similar to gases? Okay, so for 2, what does an increase in temp do? Well, the increase in temperature does what to our energy level? Increases the energy level. What does it do to our speed of particles, Justice Lee?
Makes it go faster.
Makes
have
it go
more
faster.
energy.
Have more energy. And then finally, how does this compare to what you learned about gases? So if we know particles in gases are always moving, what do we know particles in liquids are always doing? Yeah, they're always moving. Okay, so get those down for 2A and 2B. Okay, thank you, Alex.